in this problem, I like to first of all call this problem a creative engineering problem, because what we're trying to do is we're trying to engineer matrices that will do what we want them to do. Sometimes we refer to these as dummy matrices because they do nothing except either add stuff up for us, or allow us to add stuff up, or manipulate the columns in some way. So we're given these different earnings regarding Captain America and Harry Potter, and how much they brought in over a 5-day period, and then the number of theaters that were showing these films, the typical number of theaters that were showing these films. So we notice that these are all the same, and they're all the same number of theaters for Harry Potter. Needless to say, Harry Potter, of course, killed in theaters. Captain America did okay, but not so much. So the first thing we want to do is we want to use matrices to find the daily gross earnings for each of the two films. Okay, so what does that mean exactly, the daily gross earnings for each of the two films? Well, we just want to know for each of these 5 days how much was brought in. Well, this is how much was brought in per theater in this matrix, in this table here, and in this matrix that I have built of this table. And this one actually tells me the number of theaters. So, well, I want 3715 times the average earning per theater to give me the total earnings for those theaters combined. So I'm going to think about this as, all right, well, what do I actually want to do? Well, I want to make sure that this guy gets multiplied by, this column gets multiplied by 3715. So the first thing I'm going to do is create a matrix and say, all right, well, this is a 5 by 2. 5 by 2. I still want to end up with a 5 by 2. So what does that tell me about what this matrix has to be? 5 by 2, well, the inner dimensions have to be the same, so it's got to be a 2 by something. Since I want it to be a 5 by 2 with the inner dimensions matching, that means the second matrix has to be a 2 by 2. So that my resulting matrix is the same thing, but gives me all the totals. So I know that the value that I want to drop on top of this column is going to be 3715. But coming down over here, I know I'm going to have to multiply this by something, and I'm going to add a multiple of this to that. Well, I don't really want the Harry Potter total to be in the Captain America column. So what I'm going to do is I'm going to put a 0 in there. That way what I'm taking is 3715 times 6918 plus 0 times 20,816. And that falls all the way down the levels to the very bottom, and it's only taking this Captain America into account. Well, this is a 2 by 2, so I'm going to have another column here, and I'm going to do the same thing, except now I want the second column in my resulting matrix to include Harry Potter totals. So I know there are 44,375 theaters playing it each day, and so that will, if you think about this column is plopping down and crashing down this structure, well, you don't want to multiply Captain America by anything other than 0, so that you get 0 times Captain America plus 4375 times Harry Potter. So let's see if this makes sense in terms of working. So the first thing I have to do is go create my dummy matrix in my calculator, and I'll make this a 2 by 2, 3715, 0, 0, 4375. And now I'm going to just go ahead and multiply to see if I actually get, and I can double check it later to see if I get what I want. So now I'm going to do A times B, and well, there it is. So there's my 5 by 2 that I wanted, and I just have to ensure, does this make sense? Maybe check a couple of these values. Well, if it is in fact the case that if I take 3715 times 6918, I get $25,700,370. Similar for all these values here, you can double check that. And really all I'm doing is taking this column, crashing it down on top of this. Matrix operations require addition of some multiple of the second column, so I make that a 0 multiple. So that's kind of the creative engineering that we have to do here. Part B says, find the total gross earnings for each of the two films across the 5-day period. So we're looking for the total gross earnings. That is, we want to basically be able to add up all these values together. So what do I really want? At the end of the day, I want a 2x1 that's going to have Captain America and Harry Potter with the sums of all the amounts. That is, this times this, plus this times this, and so on and so forth. So how am I going to do that? Well, really, I already have this matrix that has the total for each day. I just need to be able to add up all these values. Okay, so I want my matrix to be a 2x1, but this creates a 5x2. So that must mean that I need to multiply something out front. And what am I going to multiply out front? I'm going to multiply something by 5 so that my inner dimensions here match. And because I want there to be one row, I'm going to make it a 1x5. So what matrix do we know that adds up all these values without changing them individually? Well, how about the 1 matrix? Matrix that's just full of 1s. That way when this guy crashes down on top of this. Now remember, order of multiplying matrices is associative, so I can do this times this first and then plop it down on top of this guy. And so what that'll do is it'll take this number times 1 plus this number times 1 plus this number times 1, and it will add up the columns. Then I crash the second column here on top of that and it sums those up. So I'm going to create, I'll call this matrix C, which will be my 1x5. Whoops. I'll create matrix C to be my 1x5, and now I'll just enter 1, 1, 1, 1, 1. I will quit out of here, and I want to do C times A times B, because this is my C matrix, my A matrix, and my B matrix. So I'll do C, A, B, enter. And that seems pretty reasonable. There's a 2x1. We can double check this. We can actually go and manually add the columns, but I think we're okay. This should be right here the total of all the Captain America revenue and all of the Harry Potter revenue for all these theaters. Okay, so we have that created, Next, what we want to do is, using matrices, find the total gross earnings for each day for the 2 films combined. Wow, okay, so that looks like, I know that if I do A times B, that'll give me the total revenue. We already know that. That's what we had calculated back in Part A. But now what do I want to do? That's just going to give me, type in A times B, whoops, second matrix B. So there are my totals, and I just want to add all the row values together, but leaving the columns intact. So I know that this is a 5x2. I know that this is a 2x2. I want to end up with what? Well, I still want 5 rows. So I still want 5 rows. And, oops, sorry, I'm not going to do that. So this is okay, this dimension's all right. But I want to end up with just 1 column. So that must mean to end up with 1 column, I've got to have a 1 out front here, so this ends up being a 5x1. But in order for this matrix to match the inner dimensions here, this has to be a 2x1. Okay, well, what 2x1 do you know of that will add up this plus this? Well, it's got to be the 1 matrix, the 1 and the 1. So if I collapse this down on top of this result, I should be able to get the sum of the 2 films combined for each day. So what I'll do is I'll come over here, I'll create a new matrix, matrix D, and matrix D will just be a 2x1 which contains 2 1s. And now I can do, so this is matrix D, A times B times D, whoops, A times B times D, and voila, that looks to be sufficient. I can kind of go back and add up 2 values and make sure, just pick a random one, make sure that these actually do reflect the daily totals, which they seem reasonable given the size of these numbers. And so that's kind of what we call creative engineering with matrices, to basically be able to do the quick operations that we want it to do.